We are doing equations that now have variables on both sides of the equal sign. So the reteach is a good way to do notes. And it says to solve an equation with variables on each side, use the properties of equality to write equivalent expressions. So we're just going to move variables to one side, numbers to the other side of the equation, and then the last step is typically to divide. So here are some of the notes that Mrs. Smart typed up. So step 1, you guys are good about this, draw the line. That way you make sure you have whatever you do on the left, you do on the right. She calls them math ninjas. Identify the math ninjas. Make sure you know that she calls this, how many X's are really here?
2.
1. Thank you. That's what I was looking for. This is really an imaginary 1 here. She calls that a math ninja because it's stealth, I guess. We will add or subtract variables to one side of the equation. It always helps, if you can, to move the lesser of the two variable terms. It doesn't always make sense, but a lot of the time you're able to do that. Then you undo addition and subtraction. Then you undo multiplication and division. And then we check. So let's see how we do this. So this equation has variables on both sides, but only a constant on the right-hand side. Have we talked about the whole Thanksgiving table thing? Okay, so I don't know if your family did this, but my family, when we all got together, it could be done at Christmas too. The kids had to sit at one table, and the adults had to sit at another. And then when I probably was your age, I was like, I'm so grown, I'm going to go sit at the adult table. And they were like, get to the kids' table, because they had to talk about Aunt Sue and Uncle Nick and stuff. Just kidding. But anyway, so think of anything with an X is has to be separated to one side. Anything with a number is like you kids having to go to the kids' table. They have to be on opposite sides. They need to be separated. So since the number is already on the right, the constant is already on the right, we're going to move the variable term over here to be with the 4. So this is what she calls a math ninja. There's really a 1 there. So we are going to subtract 1x from both sides. I should have drawn the line. It's kind of crooked. We're going to subtract 1x, that's an x, from both sides. What happens is it'll cancel on the right. 4x minus 1x is 3x equals, bring down the 27. Now this is just a one-step equation that we've been doing. You already know how to do this. So we divide both sides by 3. And what does x equal? 9. 27 divided by 3 is 9. Remember, you have calculators if you need to use them. You're more than welcome to. So when you go to check, you go back to the original equation. 4 times 9 should equal 9 plus 27. Since it's the same variable, it's x, that means that it's x on both sides. It means it will be the 9 gets plugged in. So 4 times 9 should equal 9 plus 27. Does everybody see that? 4 times 9 should equal 9 plus 27. So what is 4 times 9? 36. And what is 9 plus 27? 36. So it works. That works. Let's look at example 2. I'm going to write it over here. 3x minus 16 equals 5x minus 4. I'm going to draw my line. There are no math ninjas, but you do understand that this means 3 times x, and that means 5 times x. Is this 16 positive or negative? It's negative. And what about this 4? It's also negative. All right. The 16 is negative, and the 4 has the subtraction, so it's considered to be a negative. Now this is what I'm talking about. If you can, move the lesser of the two variable terms first. So what's less, 3x or 5x? 3x. So let's subtract 3x. Do not subtract something that, you always subtract x's from other x's and plain numbers from plain numbers. When you did the pouches, remember, you could only subtract coins from coins and pouches from pouches. Don't put that under here. You're not subtracting 3x from 16. You can't. So line them up. So that would cancel. You bring down the whole negative 16. And then what is 5x minus 3x? 2x, and then just bring down minus 4. Now, do you see how your variable term is now on the right? So guess what we're going to do next? Who can tell me?
Minus 2x on both sides.
No, we already took care of the variable term. We have to move the negative 4. So how do we change the negative 4? We're going to add 4. Yes, we have to add 4 to both sides. That'll cancel over here. You bring down your 2x equals negative 16 plus 4 on your calculator will give you negative 12, or in your brains. And then this is saying what times 2 gives you negative 12. How do we undo multiplication? Divide by 2. Very good. X equals negative 6. So when you go to check this, I'm going to have to do this a little bit above. You'd have 3 times negative 6 minus 16, and it should equal whatever 5 times negative 6 minus 4 is. Now this part you can put right in the calculator. You can do 3 times negative 6 minus 16. You don't have to write out and show every step. I just do because I'm the teacher. So this would be negative 34 equals negative 34, and that's what you want. If you get 2 different things on each side of the equal sign, try like so if you get that one number doesn't equal the other, try the opposite sign. Let's go to this one. This is another one of those things that are like math ninjas. There's really an imaginary 1 here. So I'm going to draw the line. Which is the lesser of the 2 variables, the 2x or the 1x?
The 1x.
So we're going to subtract that from both sides. You're left with 1x, which you could just put an x there. It won't make a difference, but if it makes you feel better, you can put it there. Equals, that cancels, and you bring down the 15. Now, this is now just what we've been doing in class. I think you know what to do. So now what do? We have the variable on the left-hand side, so
Minus 6.
subtract 6. Very good. Subtract 6 from both sides, and you're just left with x equals 9. Now, if you brought down the 1, you would just divide by 1, but you'd still get x equals 9. So to check it, 2 times 9 plus 6, and here's your other x, should equal 9 plus 15. Again, you can just put this in your calculator, but I prefer to show my work. So 18 plus 6 is 24. So 24 equals 24. So that's how you know your answer is correct. Number 4 is like one in your work for today and tomorrow. So make sure you're paying attention on how to do this one, because doesn't this look a little strange? X divided by 3, but you also have an x divided by 6 over here. Normally we just have 1, and we know that that means division. Well, this is how you rewrite this. Instead of x over 3, that is the same thing as 1/3 x. So that's how we're going to rewrite it. Make sure when you go to do your work for today, you keep these notes out. And then plus 4 equals 5, plus, guess what we're going to rewrite x over 6 as?
9 over 6x.
Yes, 1/6 x. And that'll make it much easier because we know how to deal with the fractions on a calculator. So now we draw the line. And out of 1/3 and 1/6, just imagine if you could eat 1/3 of a cake or 1/6 of a cake. Which one's bigger? 1/3. So let's subtract 1/6 from both sides. And does someone need a review on the calculator? It's 1, the ABC button, 3 minus 1 ABC button 6, and you get 1/6. So that is your answer. 1/6 x plus 4 equals, bring down the 5. Your variable term is on the left, so what do we move? We don't know? We don't know what to move?
Minus 5.
The 5, well, if we subtract 5, we're left.
Minus 4.
Right. If what happens is if you move the 5, there's nothing left over here. So you have to move the 4. And how do we move a positive 4? Yes. So bring down 1/6 x equals 1. What does this mean, having one thing right next to the other? Multiplication. How do we undo multiplication? Division. And it looks a little strange, but you have a calculator. This is still 1 divided by 1/6. Practice that in your calculator, and what would you get? 6. You have one candy bar, you're going to divide it into sixths. You have 6 pieces. Really, they're small, but you still have 6. And you could go back to the original equation to do the check. Hopefully I have enough room. You could do just 6 divided by 3 plus 4. Oops, that's supposed to be a plus. You can go back to the original because you know that means division. So that's not a big deal. It's just this is way easier to solve it when you change it like that. 6 divided by 3 is 2. And 6 divided by 6 is 1. So oddly enough, that is your answer and that's your check number. Clearly that's not normally what happens. See, here our answer was x equals -6 and your check numbers were -34. So that's just a coincidence. All right, just a couple more. This one, number 5, has a lot of negatives, so we have to be extremely careful. So let's see, we'll draw the line. Don't forget, the notes are right here. Like, if you're lost, we can go back to that. Are there any math ninjas, or is there anything that we could maybe put in to make it easier? What? Yes, the -x. So what can we put in front of it? 1. So everything here except for the 8 has a negative sign in front of it. So we're going to move the -3x because that's less than. It would be further to the left on the number line than -1. So we're going to add 3x to both sides. Again, your ultimate goal is get variables on one side, constants or plain old numbers on the other. That's your goal. Bring down -12. -1 plus 3 is plus 2x. Bring down the 8, and then this just cancels. And then this now is what you've been doing. And this is the proper way to show your work. Don't make up your own system. This isn't my system. This is how it's done. Again, I think I've told you before, if someone said skip, and you started, I don't know, crawling, and you're like, no, this is how I do it. This is how I skip. That's not skipping. Okay? This is not, you can't make up your own system. This is how you solve equations. Now what do? Our variables on the left, so what can we move? We want variables are already over here. We want numbers over here. We have to move the 12, and what do we do to move it? Add it. We add 12. So we add 12 to both sides, which makes it cancel. We have 2x equals 20. And you know what times 2 gives you 20? 10. So you divide both sides by 2 to show your work, and x equals 10. So your check would be -12 minus 10 equals 8 minus 3 times 10. You always go back to the original. So -12 minus 10 is -22. And then 8 minus 30 will also give you -22. One more. Word problems are very common. You probably do them and you don't realize them. Like in real life, you use this kind of thing often. You try to weigh the pros and cons. Like, should I go with this company or should we go with this company? Should we go with this cell phone plan or should we go with this other family plan? So you actually do this a lot, or your parents or your grandparents. We all use this. You just don't actually realize this is what you're doing. So it says Write and solve an equation to find the number of miles a rental car must be driven in one day for each company to cost the same. So if you're looking for them to cost the same, you want to set them equal to each other. So charge per day, you get charged $25 at Rentals R Us, no matter what, plus how much per mile? 45 cents. So that's going to be 45x. Per each, that's what gets your x. So that's going to equal, can anyone tell me what it should equal then on the other side? 40 plus, yes, 25 cents x. Because it's 25 cents per mile. So it's cheaper per day for this rate, but they charge more per mile. This one charges $15 more per day, but they charge less per mile. So that's why we have to figure out how many miles you would be driving to make this make sense and be equal. So now it's just a regular equation. What's less, 45 cents or 25 cents? 25 cents. So subtract the 25x from both sides. Again, x's from x's, meaning variable terms can only be subtracted with other things that have a variable, and then numbers from numbers. Bring down the 25, because we didn't use it yet. 45 cents minus 25 cents, you'd have 20 cents left. Now, your calculator's not going to give you the extra zero. You don't need it, but people understand money, so I'm just going to keep it. And then that will cancel. Our variable term happens to be on the left again, so what are we going to move? What's attached to the variable term? What's over there with it? 25. Yes. So how do we get rid of a positive 25? Very good. That will cancel. And it doesn't matter that this is a decimal. You solve it the same way if it were 2x. If this were 2x equals 15, what would you do? What if it were 2x equals 15? What would you do to solve it? Divide by 2, but it's not a 2, it's 0.2, big deal. So you divide by 0.2 on both sides. You still do it the exact same way on the calculator. You can't really see that. To get 75. So you'd have to drive 75 miles per day, or in one day, to make them equal the same thing. I know you don't remember this, but you've done this before when we did the pouches and the coins. You did multi-step equations. But we're moving away from the pictures and we're just using the numbers. Your work for today